Okay, I am going to get started. And today we are for sure going to cover 7.3 and 7.4 and hopefully get to 10.1. They are all a lot shorter than normal sections. Okay, so we should be able to get to all three. Okay, so let's start with 7.3. In 7.3, what we are going to be doing is finding the least common denominator between some fractions. Okay, so what you're doing when you're finding the least common denominator is you are trying to find the smallest thing that all the denominators will go into, or the smallest thing you can turn the denominators into. Okay, so on number one, you have two fractions, 1/6 and 7/15. Okay, so the easiest way that I have found for this to happen is when you are trying to find the least common denominator, or the smallest number, in this case that 6 and 15 will both go into, is always go to the biggest denominator. The first thing you're going to say is, well, if 6 goes into 15 evenly, then 15 would be the least common denominator. It's just that when you divide, when you try to see if 15 divides by 6 in your calculator, you will get a decimal, which means it just doesn't go in there evenly. So then you want to find this is why you choose the biggest one, because now you want to find the very next thing that 15 goes into. So first thing we tried was 15. That's the first thing 15 goes into. The next thing that 15 goes into will be whatever 15 times 2 is, which is 30. So now we need to see, does 6 go in to 30? Or in other words, can you divide 30 evenly by 6? And you can just check it in your calculator. You do get a whole number, which simply means 30 is your least common denominator. Okay, and we'll do this in the next section, you were going to add or subtract these two fractions together. Remember, in order to add and subtract fractions, you have to have a least common denominator, which means you're going to have to find this number before you can add those two fractions together, and then turn the denominators of these two fractions into 30. Okay, so that's what we're doing here is, first of all, we are just finding the least common denominator. So 30 is the first thing that 6 and 15 will both go into evenly. All right, let's look at number 2. You've got 5/6, 3/10, and 11/30. So again, go to the biggest denominator, which is 30, and say, okay, what's the first thing that 30 goes into, which is whatever 30 times 1 is, which is obviously 30. Then you say, okay, now do the other denominators go into 30? So you just try it. Divide 30, divided by, do this next one, which is 10, which does give you a whole number. So 10 is good. Then do 30 divided by 6 to see if 6 also goes into 30, which it gives you a whole number, which means it also goes into 30, which means 30 is the first thing that 30 goes into evenly, 10 goes into evenly, and 6 goes into evenly. Okay, I'm going to do one more before we move on to number 3. Okay, so we're just looking at these 3 fractions. And finding the first thing that they'll all 3 go into evenly. So let's go to our biggest number, which is 14. 6 doesn't go into 14 evenly, and neither does 8. So now we need to do, the next number that 14 goes into is 28. So let's see if these other ones go into 28. So 14 divided by, not 14. To 28. So 28 divided by 6 gives you a decimal. So it's not 28. So what's the next thing that 14 goes into? Well, that'll be 14 times 3, which gives you 42. 6 actually does go into 42, but 8 does not. So we're moving on. What's the next thing? So do you see the rules here? I just do the next thing that 14 goes into, which would be 14 times 4, which gives me 56. So let's see, 56 divided by 6 gives me a decimal again. So you see, this could go on for a little while. Let's go to the next one. 14 times 5 gives me 70. But again, if you divide 70 by 6, it's not going to go in there evenly. I'm going higher. 14 times 6 gives me 84. If I divide 84 by 6, I get a whole number. So 6 is good. But let's try the 8. What is 84 divided by 8 gives me a decimal. So I can keep going. Fourteen times 7 gives me 98. And when I divide 98 by 6, I get a decimal. Let's see, 14 times 8 gives me 112. But 112 doesn't divide by 6. So I can keep going on and on and on, but you're just going to have to keep going until you find the first thing. Ooh. It's going to be high. I'm still going. And again, I'm going to edit that last part out. So 14 times 1 gave me 14. 7 goes into it, but 6 doesn't. 14 times 2 is 28. Again, 7 goes into it, but 6 doesn't. But when you get to 14 times 3, you get 42. Let's see, does 6 go into 42 evenly? When you divide 42 by 6, you do get a whole number. You get a 7. When you divide 42 by 7, again, you do get a whole number. You get a 6, which means 42 would be the least common denominator with those 3 fractions, okay? All the ones that we have to do, we'll be able to get to, unlike, I picked horrible numbers last time. So these right here will all go into 42 evenly. And the ones that you're going to use will also get there that quickly. You won't have to go through 1,000 numbers like I did on my last numbers. Okay, now let's look at number 3. What if your denominators are not numbers? What if they're variables with exponents? Okay, there's actually a very simple shortcut for these. Okay, if your denominators are variables with exponents, all you have to do is find the highest exponent, and your least common denominator is going to be whatever that term is. So whatever your highest exponent is, you're going to choose that term as your least common denominator. Okay, so there's an easy shortcut for that. Okay, now let's look at number 4. Let's see, my fractions are negative 2 over 7z. And 14 over 2z. So now I have letters and variables. Treat them separately. So let's do the number part first. So again, you're finding your highest denominator, which in this case is a 7. And you start seeing what 7 goes into. So the multiples of 7, the first one would be 7, but 2 doesn't go into it evenly. What's the next thing that 7 goes into? Well, 7 times 2 is 14. So 7 goes into 14, and so does 2, right? 2 also goes into 14 evenly. So the number part of the least common denominator is 14. Now do your variable part. They each have a z. What is the highest exponent? Well, they both have the same exponent, right? So the highest one is z to the first. So just z. 14z is what the LCD would be. And the last one in this section, number 5. The fractions are 15 over 2x plus 10. And negative 5 over 7x plus 35. So looking at my 2 denominators, first of all, something different between these denominators than the last one. These denominators have 2 terms, right? They have 2 separate terms separated in both cases with a plus sign. So what you're going to do, if your denominator has more than one term, see if it needs to be factored. See if there's something in common that you can pull out, or if it's a difference of squares. Any kind of factoring that you can find is what you're going to need to do first. So looking at the, remember, you don't care anything about the top. Looking at these 2 terms, what do they have in common that you can pull out? They both have a 2, right? 2 goes into both of those. So if I pull out the 2, let's see, and get rid of, so if I pulled the 2 out of both of those, I'd have x plus 10 over 2 is 5. So there's that denominator in its factored form. Now let's look at this other denominator. What do they have in common? Or in other words, what goes into both of these? A 7. So let's see what I have after I take the 7 out of both of those. If I take the 7 out of this first term, I have an x plus 35 over 7 gives me 5. So here's the two denominators that I'm looking at in factored form. So let's see, just do the number part first. So again, I've got 2 and 7. So let's see, 7 is the biggest one, but 2 doesn't go into 7. So what's the next number that 7 goes into? It would be 14, right? Because 7 times 2 is 14. And does 2 go into the 14 that 7 does? Yeah, 2 goes into 14. So 14 is going to be the number part of the least common denominator. So let's see, they both have x plus 5 to the first power. So again, anytime you're dealing with something that has an x in it, you're just looking for the highest exponent, which in this case, again, is 1. So my highest exponent with the x plus 5 is 1. So that's all I need to use is the x plus 5. Okay, now we're going to move on to 7.4 now. And 7.4 is actually going to be adding and subtracting fractions. And for the most part, all the way until the end, they're actually going to have the same denominator. So we won't have to worry about coming up with the LCD until the very end. Okay, so here's the rule. When you are adding fractions, like number 1, every time, if you are adding fractions that have the same denominator, you're going to make a new fraction over that common denominator and simply rewrite your numerators up top. So up top, I'll have 5 plus 7. And then you're going to combine like terms up top, which means add or subtract, depending on what that says. So if I add the 5 and the 7, right, I can put those together. They are like terms. I will get 12 over 16. And then what do you do with that answer? You're going to simplify it. Okay, it's always going to say simplify your answer. And remember, if you don't like reducing fractions on your own, you can use that math inner function on your calculator. So we have 12 over 16. So let's see if it reduces. So I'll just hit enter. If it's a decimal, hit math, enter, and it will reduce that fraction for you to 3/4. Okay, so again, the steps are, if you have a common denominator, we're going to turn these two fractions into one fraction over that common denominator. So I just put this common denominator here, rewrite the numerators up top, add or subtract, combine any like terms that you can up here, and then reduce your answer. So let's look at number 2, following these same steps. Let's see, I've got 25 over a plus 40. Minus 13. plus 40. So let's see, do I have a common denominator? In other words, are these the same? Which they are. So I'm going to create a new fraction over my common denominator, just like I did on the last one. So I turn the two fractions into one, then rewrite the numerators with whatever sign is showing. So I'll have 25 minus 13. Just bring over your common denominator. Combine any terms that you can. So I have 25 minus 13 up top, which is a 12. And then see if you can simplify this. It's just that you can't simplify anything. First of all, that's not just a 40. That's a plus 40. You can only simplify if that 40 was multiplied with something, or in other words, if it was a factor. Okay? If a number is added or subtracted with something, you can't use it to simplify. So that 12 over a plus 40 is as far as that one can go. All right, let's look at number 3. Six y over y plus 2 plus 12 over y plus 2. So I have a common denominator, yes. So I'm going to just create a new fraction with everything over the y plus 2. So again, I'm just going to rewrite these numerators. So I have a 6y here plus 12. Now, on the last problems, I've been able to combine those two terms because they were like terms. However, I can't put a y with a term that's not a y. So I can't combine these terms. So here's what else I'm doing to see if this will simplify. And we did a little bit of this on Thursday. Looking at the top and the bottom, can you factor anywhere here? In other words, is there anything? What's the biggest number that goes into 6 and into 12? Goes into them. Let's see, 6 goes into 6. The 6 also go into 12. And it does. Which means you can, it's that common factor that you can pull out. So let's see, if I pulled the 6 out of both of these terms, if I pulled the 6 out of the first term, all I'm left with is that y, plus, if I pulled the 6 out of the second term, I'd have 12 over 6, which is 2. I can't do anything with the bottom, right? I can't combine those. There's nothing in common I can pull out. So I'm just going to bring over that y plus 2. So I notice that this y plus 2 factor is the same as this y plus 2 factor, right? It's a factor because it's multiplied by something. So this y plus 2 can cancel that one. So all you're left with is 6. All right, let's look at number 4. X over x plus 4 minus 4 plus 7x over x plus 4. Common denominator. Yes, which means you're just going to create a new fraction and put this all into one fraction. Okay, so my first term, I have an 8x. Now, be careful if you are subtracting and what you are subtracting has more than one term, because you're going to subtract the 4 and the 7x. If you just put minus 4 plus 7x, you're not subtracting this whole thing. You're just subtracting the 4. This says to subtract that whole second fraction. So what does this minus turn this plus into? A negative. So again, if you are subtracting and the numerator of your second fraction has more than one term, make sure your minus goes to all the terms of that second fraction. So that's why that turned into a minus 4 and that turned into a minus 7x. Okay, so now let's look at this numerator. Is there anything that can go together? What can go with this 8x? Well, that minus 7x, those are like terms, right? They are both x's, so I can put those together. So let's see, what do you get when you put 8x and negative 7x together? You get just an x, right? Because you have 1x. So combine those. I'll just bring over that minus 4. I can't do anything with the bottom, so I'll just bring it over. So I'm looking to see if there's any factoring to do in the top or the bottom. But in the top, there's nothing in common I can pull out. There's not a difference of squares because that's not squared. There's nothing I can do to factor in the top and the bottom. And since they're not the same, I can't cancel them. So that's just simply as far as I can go with that one. All right, let's look at number 5. Seven x over x minus 5 minus 5x minus 7 over x minus 5. So again, be careful because you are subtracting. When you're subtracting, you want to make sure your minus goes to all of that. So let's see. Common denominator, yes. So that just means you're going to make a whole new fraction by putting all this together into one fraction. So I'll just have the 7x. Now remember, this minus goes here and there. So let's see, it turns that to minus 5x. What does it turn this into, though? So since it's minus negative 7, it's actually plus 7. So let's see, 7x minus 5x, I can put those together. So I actually just have 2x up there. Bring over my plus 7, and it's over x minus 5. So I'm looking for something in common up top. Nothing in common to pull out. I can't do any factoring there. I can't simplify the bottom by factoring. So again, that's just as far as you can go with that. Okay, number 6. Got x squared over x plus 8 plus 8x over x plus 8 So let's see, common denominator again, yes. So I'll just create my new fraction over that common denominator. Up top, I'll have an x squared plus, over here, I'll have an 8x. So let's see, up top, I cannot put those together, right? Those are not like terms. You can't put a squared with just a plain x. Remember, in order to put all the eggs in the same basket, each term has to have the same exponent. So I can't put these together. So let's see, do they have anything in common? Yes, they do. Not looking down here, just looking up top. Do they both have an x, which means you can pull out an x and put in parentheses what is left. So if I put in parentheses what is left, by pulling the x out of both of those, well, let's see, if I had an x squared, but I took out an x, then I'm just left with an x, plus, well, here I had an x, but I'm taking it out. So the only thing you're left with in this second term is that 8. So let's see, just bring over that x plus 8. And notice what you have. This x plus 8 factor cancels this one. So what is the only thing you are left with? The only thing you're left with is that x. Okay, number 7. X squared minus 2x over x plus 4 plus negative 24 over x plus 4 So let's see, my common denominator, yes, x plus 4. Let's rewrite all the numerators up here. So I've got x squared minus 2x. Now look what this says. I have plus of negative 24 plus a negative. If you are adding a negative, that's just the same thing as saying minus 24, right? If you add a negative to something, you might as well just say you are subtracting it. Now, none of these terms can go together, right? None of those terms are like terms that you can put in the same basket. So I need to see if I can factor what is in that numerator. So let's see here. I have 3 terms this time. Nothing's in common with all 3 of them because, first of all, this one doesn't have an x, so I can't take an x out. They don't all divide by the same thing, right? Because these both divide by 2, but this one doesn't. So there's nothing in common with all 3 of them. This is one of those trinomials, but it's the good kind, right? So trinomials have 2 factors. It's the good kind because it's just an x squared, okay? We like those because the only way to get x squared is with that x and x. Now, remember how we did these in our calculator? Because what are you trying to do? You're trying to find the numbers that multiply to negative 24 and at the same time add to negative 2. So let's see how we did that. You went to your y equals button and cleared out whatever was in there. You put in that negative 24. That's the number you're going to put in your y equals, is that negative 24. So negative 24. Then remember what we did here. We did divided by x. And then we went down and did the same thing again. Negative 24 divided by x plus x. And then we did the table, second table. So the second button, and then your graph button to get to the table. Now remember what you're looking for in this last column is you are looking for whatever this middle number is. So I am looking for -2 in my last column, which I see it right there on the top, which means these are the numbers that will do what I want them to do. They will multiply to -24, and at the same time, they add to -2. So I need a +4 and a -6 in my factors, a +4 and a -6. Nothing can happen here, right? So I'm just going to bring over that x plus 4, and then what do you notice that you can cancel now that this is in factored form? The x plus 4's cancel. So all you're left with is x minus 6. Okay, last one for this section, number 8. So all of the ones that we have been doing so far have had the same denominator. But look at number 8. You have 1 over 8x plus 2 over 3x. So I can't use the same method yet because I can't make this a new fraction over a common denominator like I've done on the first 7 because they don't have a common denominator. So that's what I've got to work on first. So this is why we had 7.3 before 7.4 is the first thing we have to do is find the least common denominator. So remember, when you have numbers and variables, we're going to treat them separately. So the first thing we're going to do is find the first thing that 8 and 3 will go into. Not what goes into them. We're not trying to pull something out like greatest common factor. We're saying, okay, 8 goes into 8. Does 3? No. What's the next thing 8 goes into? Well, 8 times 2 is 16. Does 3 go into 16? So you would check that by saying, okay, 16 divided by 3 to see if 3 goes into 16. It gives you a decimal, so it doesn't go in there evenly. So then I go to the very next thing that 8 goes into, which is 24. Let's see, does 24 divide evenly by 3? Which gives me 8, which is a whole number. That's all I'm worried about is that it's a whole number, which means 24 is the least common denominator number part. Then remember, if you have x's, you're just looking for the highest exponent. My highest exponent is just x to the first power. So that's all I need is x to the first power. There's your least common denominator. So what that means we are going to do is turn both of these denominators into 24x by multiplying them by whatever will do that. So let's see, if I have 8x, what do I need to multiply that 8 by to make it 24? I'd have to multiply it times 3, right? Won't 3 times 8x give me 24x? It will. Whatever you do to the bottom, you have to do that same thing to the top. The reason for that is if you multiply something by 3 over 3, what is 3 over 3 equal to? It's equal to 1, which means essentially I'm just multiplying this fraction by 1, and if you multiply something by 1, does it change its amount? It doesn't. right? It may write it in a different way, but it's going to be the same amount, right? 10 million times 1 is still 10 million. 1 over 8x times 1 is still going to be 1 over 8x. It's just going to look different. Let me show you what I'm talking about. What will this turn into at the top? 3 times 1 gives me 3. 3 times 8x gives me 24x. But if you wrote that in simplest form, 3 over 24x is 1 over 8x. They are the same amount. Let's do the same thing to this one. What do I need? I need to turn its denominator into 24x. So I'll need to do the 3 times 8 this time. And again, I'll do it on top and bottom. So let's see what this one's going to turn into. Just bring down the plus. 2 times 8 gives me 16. 3x times 8 gives me 24x. So again, if I reduce that, it would reduce to 2/3. But when instead of reducing it, it's kind of like you're blowing it up. Now I have written this 2/3 x and this 1/8 x in ways that they have the same denominator, and now I can add them together. So my common denominator, just like the previous problems, now I have a common denominator, so I can turn this into one fraction over that 24x. Just write your numerators, 3 plus 16. And then see what you can do. Can you put 3 and 16 together? You can. So 19 over 24x. And then you would just see if 19 over 24 reduces by math entering it. So 19 over 24, enter. Math, enter, and it's still 19 over 24, which just means this doesn't reduce. Okay, now I'm going to write another one up here, not like the last problem I made up, and all right, so what is the first thing that you could turn 7 and 21 into? So let's see, 21 is the biggest one, right? What's the first thing that 21 can be? 21. Let's see, will 7 go into 21? Right, because I'm coming up with the least common denominator first. 7 does go into 21. Okay, if you used a different number, don't necessarily erase it yet. If you went up to 42, don't erase your number yet. What is the biggest exponent? I have x to the first and x to the first, so x to the first is my biggest. So 21x is my least common denominator, which means what do I need to multiply this first fraction by? 7 times 3. Do it on top and bottom. So let's see. That's going to turn into 9 over 21x. Plus, remember, the whole point of this step is to get the same denominator. It already is the same now, which means I can just bring this fraction down, or I can think, well, I just need to multiply it times 1, right, to make it 21x, since it already is 21x. 5 times 1 is 5. So let's see. I do have the same denominator now, 21x. Can you put, I'm going to put the numerators together, so 9 plus 5. I can put those together, which gives me 14 over 21x. And then let's simplify this one. Let's see if it simplifies. So put 14 over 21 in your calculator. And let's math enter it. which gives you 2/3, which means the 14/21 does reduce to 2/3. So up top, all I'm left with is the 2. In the bottom, 3x. So 2/3x. Okay? All right, I am actually